Well, hello, and welcome to Miss Duggar's At-Home Math. I'm so glad you came. I thought maybe you wouldn't, but here you are. That's great. Let's get started. Before we get started, you're going to need a few things. You'll need your book, a calculator, a piece of paper, a pencil, and let's turn off all those distractions. Turn off your TV and mute your phone. You go do those things. I'll be right here waiting. You're back. Very good. We'll start with labeling your paper. Right in the upper left-hand corner, AHM. Do you know what that stands for? At-Home Math. We're going to be working on lesson 10.6, so write that. And on the right-hand side, your name and date. Hello. So, today we're going to learn about the distance formula, which is derived from the Pythagorean theorem. Remember Pythagoras? I have a picture of him. What do you think? Handsome fella. Those guys all looked the same back then, I think. Anyway, the distance formula is derived from the Pythagorean theorem. And hopefully you'll recall that, so the distance formula is used to determine the distance between 2 points. Say I have these 2 points, 1, 5, and -2, 1. And I want to know the distance between them. I can see, if I were to draw a right triangle, that this distance is actually the hypotenuse. So I can use the distance between 0.15 and 0.11, where that vertex is, as the difference in the y's, and that'll tell me how long this is. So I take the y value here, the y value at the vertex, which is the same as this one. So 5 minus 1 is equal to 4. That length is 4 units. And that's really 5 minus 1. Same thing is true here. I can take the value for x, which is -2, minus the value for x for this point. So the length is then -2 minus 1, or 3. Of course, I can count them up, but I don't always want to graph them just to find out that distance. So this length is x2 minus x1. So remember, the Pythagorean theorem says the hypotenuse squared is equal to the sum of the legs squared. The legs in this case would be this length and this length. So here it's going to be c squared is equal to 5 minus 1, this length squared, plus 1 minus -2, this length squared. And if I take the square root of both sides, you can see what I'm really doing here is just the Pythagorean theorem. But the distance formula states distance is equal to, this distance is equal to, the difference in the x coordinates squared plus the difference in the y coordinates squared, and then I take the square root of that. This is the important part. This is what you have to remember. Okay? All right, let's look at example 1. It's on page 636. Here's the distance formula. Distance is equal to the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. It doesn't matter, remember, whether I call this x1, y1, or this x1, y1, because I'm going to square them. All right, so find the distance between 5, 3 and 1, negative 2. All right, so distance is equal to the difference in the x-coordinates. So 1 minus 5 squared plus the difference in the y-coordinates, negative 2 minus 3 squared. I square those, I get, well, 1 minus 5 is negative 4, negative 2 minus 3 is negative 5, and I square those and I get 16 plus 25. So the square root, 16 plus 25 is equal to 41, and the square root of 41 is about 6.4 units. Ready to try one? Okay, this is what your paper's for. So, this is your first problem. Find the distance between 4, 2 and negative 3, negative 1. Show the steps on your paper. You're going to bring that in tomorrow. All right, ready? Go. Ready to check your answer? So the distance formula says I take the difference in the x coordinates. So I have negative 3 minus 4 and the y coordinates. So I have negative 1 minus 2. Subtracting, I get negative 7 squared plus negative 3 squared. So it's 49 plus 9, square root of 58. I can leave my answer like that, or I can take the square root. I think in your book it mostly just leaves them as simplified square roots. Okay? That's problem number 1. Okay. So example number 3 on page 637 shows that we can also use the distance formula to find a missing coordinate if we know the distance between 2 points. So in this case, what are the possible values for A if the distance between this coordinate pair, 4, 7, and this one, A3, is 5. So I don't know A. I'm looking for the possible values. So distance formula says I take the distance, which is 5, is equal to the square of the difference between the x coordinates and add that to the square of the difference between the y coordinates, 3 and 7. If I square this binomial, I get a squared minus 8a plus 16. 3 minus 7 is negative 4 squared is 16. I can add those terms together, so now I have 5 is equal to a squared minus 8a plus 32. I square both sides. 5 squared is 25. This just gets rid of the square root, so I have a squared minus 8a plus 32. I subtract 25 from both sides, and I end up with 0 is equal to a squared minus 8a plus 7. Now I want to factor this so I can use the zero product property. Two numbers that multiplied together give me 7 and added together give me negative 8 are negative 7 and negative 1. So this factors to a minus 1 times a minus 7. So using the zero product property, a is either 1 or 7. Ready to try one on your own? Ready to try problem number 2 on your paper? Here it is. The distance between 3a and negative 4, 5 is square root of 58. Find a. or the possible values for A. Alrighty, go. Okay, ready for the answer? The distance formula says the distance between these 2 points is the square root of 58 is equal to the square root of the difference between the x's and the difference between the y's squared. So the difference between the x's is -7 squared is 49. Between the y's is 5 minus a, so if I square that, I get 25 minus 10a plus a squared. Take the square root of both sides, I get 58 is equal to 74, these two are added, minus 10a plus a squared. Subtract 58 from both sides, I just use the commutative property here. So 0 is equal to a squared minus 10a plus 16. That factors to a minus 2 times a minus 8. So using the zero product property again, a is equal to 2 or a is equal to 8. Okay, we're almost done. Another derivation of the Pythagorean theorem is called the midpoint formula. And the midpoint is the point that's equidistant from the two endpoints. So in this case, the endpoint A with coordinates x1, y1, and endpoint B with coordinates x2, y2. M is the midpoint. Its coordinates are the sum of the x's divided by 2 and the sum of the y's divided by 2. So that's pretty straightforward. The midpoint formula then is x2. So the formula for the coordinates are the sum of the x's, x1 plus x2 divided by 2, and the y coordinate is the sum of the y's, y1 plus y2 divided by 2. All right, we'll try an example. Okay. In this example, we're finding the midpoint of the segment with endpoints -1, -2, and 3, -4. So the formula says I take the sum of the x's, -1 and 3 divided by 2, and the sum of the y's, -2 and -4 divided by 2. So that's 2 over 2 and -6 over 2, which simplifies to coordinates of 1 and -3. Voila. All right. One for you to try. Oops, I did the work without showing you the problem. So here's the problem. Find the midpoint of the segment whose endpoints are 12, 3 and -8, 3. Okay, so in this case, I want the sum of the x's, 12 and -8 divided by 2, and the sum of the y's, 3 and 3 divided by 2. So the coordinates of the midpoint are 4 divided by 2 and 6 divided by 2, or 2 and 3. Okay? So if you have any questions, like where I got this amazing dress, write them down, circle them, bring them in tomorrow. Tomorrow morning, you want to turn in the 3 problems that we did, and be prepared to get started on some work. Bye.